All right, in this lesson, we're going to look at how we can write and use quadratic regression models. Another cool thing about this is once you know these steps, if you are given a graph and it asks you to write the quadratic equation, as long as you can pick 3 points off of the graph, you can use these steps to write the equation for you. You don't have to go through a lot of work by hand. And so we've done regressions before with linear functions, and it's pretty much the same steps. We're just going to choose a different option this time. Before, when we went to stat, we typed in our numbers for L1, L2, and then we went back to stat, and then went to the right. And with linear regressions, we chose number 4, linreg. With quadratic regressions, we're going to choose number 5, quadreg. And that's going to put it in the form of a quadratic equation. We're also going to look at how we can use this menu to also save your equation in your y equals. Because there's a way that we can do this where when you go to your y equals, it will already be typed in for you, and you can use that to help look at the graph or look at a table to make some predictions on your values. So that's something that's pretty helpful. All right, so now let's go through it. Example 1 says, data was recorded about several adults' height and weight. What quadratic function can be used to model the given data? All right, and then so they've given me this table that shows height and weight. Remember that on tables, the left side is your x values and the right side is your y values. L1 is where we put x values, and L2 is where we put y values. So on my calculator, I'm going to press stat, enter, and I'm going to type in my x values. So I've got 4.65, enter, 4.9, enter, 5.05, 5.55, 6.15, and 6.3. Right? Now, you want to make sure that you're double checking what you're typing in. If it doesn't match what's in the table, you're not going to get the correct answer. All right? The calculator's not a mind reader. It can't see what's on your paper. It's relying on what you type. So double check that everything's correct. Just know that with your calculator, if you type in a really long decimal or a fraction, it's going to look like it's rounding it. But when you go back on top of it, it will show you at the bottom of the screen what it was before. All right, so don't freak out if it does that. All right, so for L2, that's my y's. So I've got 98.9, 113, 115, 141, 170, and 180. Okay, so we've got all those values in my table, and let's try something here. I'm going to go zoom. Yeah. I don't know if it'll work. Not on this one. Okay, never mind. All right, so we've got all our values in our L1 and L2. And what I'm going to do is I'm going to ask it to calculate the quadratic equation that would go through these points, or at least be really close to going through these points. And so I'm going to press stat. I'm going to go over to the right, and I'm going to choose number 5, quadratic regression. And so it's going to bring up something similar to this on your screen. It's going to say X list, Y list. That's the L1 and L2, so that's what it's referencing. We're not going to worry about the frequency list, but where it says store regression equation, that's where we want to tell it to store Y1. And so to do that, we're going to push the green button and then push the trace button, and that lets you choose Y1. All right, so we want it to say Y1 right there. And then on your calculator, you're going to go down to calculate and press enter. This one doesn't have that. I just get to press enter. All right, and when we do that, it's going to tell us our values for A, B, and C. The R squared is your correlation coefficient. It tells you how well your equation is going to fit your data, how close it is to going through all of those points. Remember, a 1 is a perfect fit if it's an R squared. And so having a 0.997, that's really close to going through all these points. So that means it predicts our information pretty well. And so what we're going to do is we're going to take the values of A, B, C, and we're going to plug them in to the quadratic equation in standard form. I'm just going to go ahead and round to the nearest hundredth since it didn't give me any specific instructions on what to do there. And so this is going to be y equals, I need my A, so 3.84 x squared plus B, which is 6.12 x, and then our c is negative, so we're going to say minus 11.80. All right, so that is what we have. Now remember, I rounded this because we had a bunch of long decimals, but this should get us close enough to picking an answer when they ask for which equation is correct. Otherwise, just make sure you pay attention. If it says round to the nearest thousandth, remember you need an extra decimal place. All right, then the next part says using the model, which is the equation. The model is the equation. What value estimates the weight when a person is 7 feet tall? So think back, we said that height, how tall you are, is your x. And so they have told me that x equals 7. So they're wanting to know, what does y equal? They want to know what the weight is. So remember how we asked this to put the equation in for y1. So if I go to y equals, there's my equation in all its glory typed out. They just didn't round it off, which is totally cool. If I go to my table, so if I press second graph, remember we have x values and y values that we can look at that are generated from that equation. So I'm going to go down to when x is 7. I'm getting out of these negatives. Here we go. X is 7. And when I look over at my y, that's about 219 pounds. And so my answer is going to be about 219.23 pounds. All right, once again, I just rounded to the nearest hundredth because it didn't give me any instructions. Just make sure you read for what it wants you to round to. All right, so we're going to rinse and repeat. We're going to do the same thing on example 2. All right, so example 2 says data was recorded about the times at a local marathon and the age of the runners. What quadratic function can be used to model the given data? And so I want to point out in both of these, it's told us which function we need. That's what tells us to choose quad reg instead of lin reg. If it had said linear function, I would choose lin reg. Since it says quadratic, I'm choosing quad reg. So we've got our table like they gave us before. Remember, left side's your x, right side's your y. So left side is L1, right side is L2. So we're going to get rid of our numbers that are already typed in. So I'm going to go all the way up and highlight L2, and I'm going to push clear, enter. And it gets rid of all those numbers. And I do the same thing for L1. And I'm going to type in my new values. 20, 22, 36, 46, 50, 56. Now I'm going to do the same for my y's. 172, 168, 153, 168, 172, 185. All right, and then so since we need a quadratic, we go stat, right, we choose number 5, quad reg. Okay, remember we want to tell it to store our equation in y1. So green trace, enter. All right, press enter on calculate. Here's all our values. So when I write my function, I'm going to round this off. I would get y equals 0.07 x squared minus 4.82 x plus 240.39. Okay, so that's my equation if it asks you for the model or the equation. And then it says using the model, so using our equation, how long would you expect it to take a person to run the course at the age of 40? So remember, age is our x values. So they told us x equals 40. We need to see what y equals. So remember, we asked it to save our equation as y1. We can see it there. So I'm going to go to my table, second graph. And I'm going to find when x is 40. Now I can keep going down, down, down until I find it. Another thing you can do is you can press second window. And you see where it says table start. We can tell it to start at 40. And then go back to our table, and boom. And so it says 157.83. 83 minutes. Right? And then once again, I just rounded to the nearest hundredth because it didn't give me any other instructions. Just make sure you're reading your problems. Okay.